Hello everyone, my name is Efehan and I'm working at Çankırı Karatekin University Department of Statistics as an assistant professor. Today, my presentation will be about the air pollution forecasting by using one of the most common use technique called ARIMA in time series analysis. Directly going into the details, let me just give some introduction about my presentation. So, as you know, the air pollution is the common problem around the world, and most of the countries are facing and trying to fight with the air pollution. And the problem of air pollution has become a much more difficult challenge for our nature. And most of the time, the air pollution can be seen in the urban areas when you compare with the rural ones. This is because of the population of the cities are higher in urban areas than the rural areas. And by increasing the population, you have much more cars and other factors that affect in the air pollution. So that's why we detect the air pollution in urban areas much more than the rural areas. So there are different indicators when we check the air pollution of each cities. But two fundamental indicators are the ozone, O3, and the particulate matter, PM10. So in this research, we use only these fundamental indicators in the analysis part. So we didn't include the other parameters. So almost every developing and developed countries, they are calculating their air quality index for each city. For example, Canada using the air quality health index, and Malaysia using air pollution index, and lastly, the Singapore uses pollutant standard index. And we can give much more examples for other countries, but these are the main ones and the early air quality indexes used by the countries. Also, many other countries having a high amount of the air pollution. For example, China. So because of this, they start declaring a pollution emergency, and they trying to go to more green ways. For example, they are trying to encourage people to use electrical cars than the cars with the gas, or they start producing the electricity by using more green ways, such as solar power, such as wind power, etc. So hopefully other countries will declare such pollution emergency declarations. Therefore, we can increase the quality of the air and reduce the air pollution. So there are also other indicators. As I said, it was PM10, and there is another indicator called PM2.5. This is the same one, but the level is 2.5, not 10. NO2, SO2, CO, O3, NH3, and PB. These are the indicators for calculating the air quality index for each countries. Also, when we calculate the air quality index, we have 6 different categories for each city or country. So these categories are called good, satisfactory, moderate, poor, very poor, and severe. So this table showing the level of each indicators. For example, if the PM10 is between 0 and 50 and NO2 is between 0 and 40 and SO2 is between 0.40 and so on. So this city or this area is called as a good area for air pollution. So they don't have any problem with the air pollution in this area. But we can have a similar scenario for a different city. Let's say they have a PM10 more than 430 and they have CO more than 34. So this area has a problem with the air pollution, and this is very dangerous for their public health and also their mother nature. So they must do something to reduce the air pollution. And each index category has an explanation, like this is called an associated health impacts. If the city is good, so their outcome is called a minimal impact. Or if the city or the area is very poor, in the category of the very poor, this may cause respiratory illnesses to the people on prolonged inhaling, and effect may be more severe in people who are living with the lung and heart diseases. So that's why it's important for countries to declare fights against air pollution. So let's move on to the analysis part. This is a diagram before starting the analysis. Firstly, we define our objective, then we collect our data set. After collecting the data set, we start doing the explanatory analysis by pre-processing the data. Then we are using the appropriate method or technique for forecasting. And after forecasting, we are comparing our result with the real data sets to see if our forecasting is successful. So let me just give info about the data set I use. So I use the data set of the air pollution of Prague, Czech Republic, between the years 2013 January to 2020 April. And we try to predict next almost two and a half years for the ozone and PM10 level. So this is the raw figure, the time series figure of the O3 level, ozone level, and this is produced by a monthly data set between 2013 and 2020. So as you see, in some months there are increases, and in some months there are decreases. By looking at this figure, we may say that there's an increasing and decreasing trend, and also in some months we may see a seasonality. But it's hard to describe directly from this graph, but this graph giving us a hint. So there is a possibility. In order to better understand, we difference the data of the ozone level, and the range of the lines change between the mean of 0. And we have the similar figure here. In some months, as you see, there is an increase, increase, and in some months there is a decrease, and decrease. This is also showing that there is an increase and decreasing trend and seasonality in specific months. So this figure showing also to capture the trend and seasonality. The gray lines are describing the raw data set, and blue lines is the seasonally adjusted data set, and the red line is our trend line. It's very similar to the first graph, but this we can see easily here the trend, increasing and decreasing trends, and some seasonalities here for the ozone level. For the different indicator PM10, we have the similar data set here. This gray is the raw data set, and the blue one is the seasonality adjusted data set, and the red one is the trend line. Similarly, we have increasing and decreasing trend in some months. We see here also a seasonality. Capturing the seasonality a bit a hard task, because sometimes we may do a mistake. So to make sure we can produce the different graph for the seasonality plot, this gives the each month in a detail for the each year. So years are showing with the colored lines here. It's a bit complicated to understand here, but when you check the month between August and September, you see a decreasing for almost every year. And after September to October, you see an increasing until October for each year. So for specific months, we see a seasonality for ozone level. And this is showing the category of the seasonality. Let's say if it's a negative seasonality or if it's a positive seasonality, and it's showing how high or how low is the seasonality is. If we start from the beginning, you see this is a positive seasonality, but it's a very small amount of the seasonality and increase until the March. And you see after March, the decrease start, and until the October, it reached the maximum negative level of the seasonalities. And once we are sure we have trend and seasonality, we start producing the ACF and the PACF graphs of the ozone level to understand the autocorrelation. And for ACF, you see there is a log at 12, also at 4, and after 12 there is another log at 15. And for PACF, we also have log at 12 here. So we here differenced our data set at log 12. And when we do this, we have these graphs. And you see almost all lines are inside our range. So now our data set is ready to be forecasting for the ozone level by differencing at log 12. For the different indicator PME-M10, you see there are logs at 1, 12, 13, and 25. And similarly for the PACF. So we try to difference our data set at log 12 again to see if we can reduce the autocorrelation problem here. And when we did this, as you see, again, our lines, all lines are inside our range. So now it's also a good time for doing the forecasting for the indicator PM10. For the forecasting, we use auto-ARIMA function in R, and this function helping us to understand the best ARIMA model by checking their scores, and it takes the minimum score of the ARIMA. So for this analysis, for the O3, we selected ARIMA 100 and seasonality of 111 at log 12. When we did this, after April of the 2020, we have, you see, the predictions here. And these predictions are pretty good for the ozone level, because as you see, it's in the average of the 50. And this is showing that for almost 2.5 years, the air pollution level, let's say the ozone level, one of the indicator of the air pollution, ozone level will be in the safe place. It will be minimum less than 25, and maximum it will be like around 75. And the average will be around 50 for the ozone. For PME-M10, R select the ARIMA 101 and seasonality of 101 at log 12. And when we do the forecasting for the next 2.5 years until the half of the 2022, you see we will not have any sharp increase or decrease. Our PME-M10 level will be changing between around 20. So this is also a good prediction. And we can say that the next 2.5 years, when we did the analysis period, we will have PME-M10 and the O3 level in the safe zone for Prague. So this graph is showing the current indicator levels of the Prague for the last 5 days. And you see here is the PME-M10 and the O3, and it's all green. It's in the safe zone. This is also supporting our results for that days. But of course, we must check for a long period until half of the 2022. So for conclusion, as I said, ARIMA is the mostly used technique for forecasting the air pollution. And this is giving a pretty good results, but it may change from city or from area to another area. Firstly, we need to check the raw data set, and we need to understand the seasonalities and the trends in the data sets. And also our findings support the air pollution level of Prague might be in moderate level in a midterm, like let's say 2.5 years. We may use a long period of data set to understand the next 5-10 years. But for a small amount of data set, it's better to use 2-3 years. So we can safely predict only 2.5 years for this analysis. And sometimes the ARIMA technique is not useful because of the nature of the data set you use. So there are other smoothing techniques you can use for forecasting, let's say Navy, let's say exponential smoothing techniques, etc. and etc. So based on your research, you may choose the technique that you want. But in our case, the ARIMA, seasonal ARIMA, was the best technique when we use for forecasting the air pollution data set. So thank you for your attention.